students, welcome to Midha Guru. In the last video, I mentioned that there are many ways to prove the Pythagoras theorem, and here I am with some of the proofs. Pythagoras theorem states that hypotenuse squared is equal to the sum of perpendicular squared and the base squared. Now, if you are in class 10th, you might have studied that using the similarity of triangles, we can prove the Pythagoras theorem. But is it the only way to prove it? Well, the answer is no. And in this video, we are going to see some of the many proofs that can be used to prove the Pythagoras theorem, and that too without using the concept of similarity of triangles. In fact, it is not even necessary for you guys to be in class 10th. If let's say you are aware with the concept of the area of triangles, area of squares and some basic algebraic expansions such as a plus b whole squared and a minus b whole squared, then you can understand and in fact you can prove the Pythagoras theorem. So let us begin now. Now here I have a triangle ABC which is right angled at C. This is the hypotenuse H, base is B and perpendicular is P. Now in order to prove the Pythagoras theorem, I will need 3 more such triangles. Of course they will be aligned in a certain manner like this. Okay, so as you can see here we have 4 triangles and one smaller square, and overall this figure is a square itself which has a side of length h. So area of this square can be written as, what is the square name? ABDE can be written as h square. Alternatively, if you will see, we can find out the area of this square by adding the area of these 4 triangles, which is nothing but 1 by 2 into b into p plus the area of this smaller square which has a side of length p minus b. So area of all 4 triangles is nothing but 4 times 1 by 2 into b into p, which is 2bp, and the area of inner square is p minus b whole square, which will simplify into p square plus b square minus 2pb. Now I can write that h square is equals to 2bp plus p square plus b square minus 2pb. Now as we can see, plus 2bp and minus 2bp can cancel out each other. So we end up with h square equals to p square plus b square. Wasn't it fun? But that's not the end of the story. Here I have 2 more ways to prove the Pythagoras theorem. Now let's check them. This method of proving the Pythagoras theorem is quite similar to the method that we discussed previously, but the orientation of the triangles is slightly different and the figure will look something like this. Now as you can see, the area of the square FADE is clearly p plus b times p plus b, that is p plus b squared, and alternatively I can say that the area of this square is also equal to the sum of the area of 4 triangles and the inner square. So let us prove this. Now I can write area of bigger square, that is FADE, is equals to p plus b whole square, which will simplify into p square plus b square plus 2pb. And I can write that area of this square is actually equal to pb, that is the area of the 4 triangles, sum of the area of 4 triangles, plus the area of the inner square, which is h square. So from this I can write p square plus b square plus 2pb is equals to 2bp plus h square. So clearly we can cancel out these 2 terms and we end up with p square plus b square is equals to h square. Again we have proved the Pythagoras theorem. Now let us talk about the third and the final proof. This proof is slightly different than the previous 2. Here instead of using 4 triangles we will be using 2 and the figure will look something like this. So here you can see we have ended up with a trapezium and we have 2 right triangles, that is ABC and EDC. But surprisingly we also end up with one more right triangle, that is triangle ECA. Now, if you know the formula to calculate the area of trapezium, then your journey is quite easy. But if you don't know the formula, then I'll just write it down for you. So, area of trapezium one by 2 into sum of parallel sides times the height. In this figure, we can say that the parallel sides are AB and AD, and the sum of these parallel sides will actually be equal to B plus P. And here the height is also given to us as P plus B. So I can write that the area of this trapezium is actually equals to 1 by 2 times P plus B, which is the sum of the parallel sides, times the height, that is also P plus B. So this finally turns out to be P plus B whole square divided by 2. Alternatively, the area of this trapezium can also be calculated by adding the area of these three triangles. Now we know that this yellow triangle and green triangle are the same. So this area will be equal to 1 by 2 times B times P. Now since we have two triangles, so the sum of area will be equal to 2 times 1 by 2 times B times P. This turns out to be B times P. And the area of this violet triangle will be equal to 1 by 2 times H, which is nothing but 1 by 2 H square. Now I can write that P plus B whole square divided by 2 is actually equal to BP plus 1 by 2 H square. Now this can further be written as P square plus B square plus 2PB divided by 2, and this will be 2BP plus H square divided by 2. Now this 2 gets cancelled and we get P square plus B square plus 2PB is equals to 2BP plus H square. Again, we can cancel out this 2PB and this 2BP, and we end up with P square plus B square equals to H square. Now you can see that we have proved Pythagoras theorem using three different ways, and that too without using the similarity of triangles. In fact, there are many more ways to prove the Pythagoras theorem. Now it is your task now to find out some of the interesting ways to prove the Pythagoras theorem. So if you enjoyed this video, then please do like, comment and subscribe to our channel Midha Guru.